Okay, so today we will see uh, a get previous year question. The Whitworth quick return mechanism is shown in the figure, and the figure is like this. I forgot to mention here. Okay, sorry, I'm bad at drawing, so whatever possible, I'm making it. This is P O A. Okay, and R is the okay. Let me draw it very fine so that everybody can understand clearly. This is R. This slider is P O A. So there is connection of one sliding pair here. Yeah, this is the Whitworth quick return mechanism. What is given here? The length OP is 300, OA is 150, and AR. Okay, so it has asked to find out the quick return ratio. So what is the quick return ratio? So for like in simple way, what we generally do, we generally find out beta for quick return ratio. Okay, generally what happens, like this diagram, we need to solve this diagram to find out the beta. What is beta? Beta, sorry, it is beta by 2. This is beta by 2, and it is assumed to be theta. It is B O, it is A, this let be R. So QRR, that is alpha by beta. So alpha can be replaced as 360 minus beta by beta. So once we are good to find out beta, then we can find out the QRR. So in this, what we were doing, so in crank slotted quick return mechanism, we generally do solve this typical diagram. So where the basic equation was OA is equal to OP, sorry, yeah, OA sin theta is equal to OP. Now once we are good to, like, we are provided OA and OP, we are good to go to find out theta, and so as we can get beta. So but once we are putting the values, OA is 150, OP is 300, this is sin theta. So is it possible, if we make this equation, is it possible to get a theta? Theta will be invalid, as 150 sin theta will not be anyway equal to 300, because sin theta ranges from -1 to 1. Okay, so this is not possible. So always remember that Whitworth quick return mechanism solved by the general figure, general diagram. Okay, so solve like that. So let me draw the general diagram for quick return mechanism. What is the general diagram for quick return mechanism? This is the crank, sorry, this is the fixed link, this one is the fixed link. Now the crank will rotate. Okay, crank will rotate like this. I'm extending this. Now make a circle with radius equal to the crank length. Now it will cut, this crank will cut at 2 points to the circle. Okay, like this. It is P, O, A, and this is R, and it is connected to one slider. Okay, now we got these 2 points as P dash and P double dash. So at some point at this distance it will occur its extreme position, and it will occur its extreme position at P2. So in Whitworth quick return mechanism, we just need to solve this triangle. Okay, and we are good to go. Here this angle is alpha and this is beta. So if we make the triangle O, here it is A and it is B dash, let it be theta, it is beta by 2. Now we know this is the crank length. OP dash is given as 300, OA is given 150. So in simple relation, 300 sine theta is equal to 150, that is OP dash sine theta is equal to OA. This is the simple relation. Now if we find out theta, that is 150 by 300, that is 1 by 2, hence theta is equal to 30 degree. Now what will be beta by 2? Will be 90 minus 30, that is 60 degree, hence beta is equal to 120 degree. Now QRR is equal to 360 minus beta by beta, that is 360 minus 120 by 120. Okay, make it a bracket here, that is 240 by 120, that is 2. Here is the answer. So what is the reason behind to follow the standard diagram to solve the quick return mechanism? As we know that in quick return mechanism, uh, crank slotted quick return mechanism, the connecting rod is fixed, which is the longest one. Okay, which is the longest one. Sorry, in crank slotted mechanism, we simply refer this figure OAP to solve the any numerical that appears for the crank slotted mechanism. But why not for the quick return mechanism? Because in crank slotted mechanism, the connecting rod is fixed, which is more than the crank in lengths, like OA is greater than OP. But while it comes to quick return mechanism, as we know that the crank itself is in fixed condition. So here OA is less than OP. So the relations, like in in Whitworth mechanism, there won't be any condition where this condition is achieved, this 90-degree condition is achieved. There will be no condition, no situation would be there where this condition is achieved. That's why in quick return mechanism, crank slotted mechanism, we are good to go with this diagram for any kind of solution. But while coming to Whitworth mechanism, we are following this diagram as the standard diagram for the solution. Hope you understand the differences between this crank slotted and this Whitworth mechanism. So hope it was easy, and we'll meet in the next video. Till then, take care. Bye bye.